geometry. So before that, let us recall the things that you have learned in the previous classes. You have learned already how to locate a point on a plane surface, a blackboard, or on a wall, on a sheet of paper. They are all planes. To find out the location of a particular point, that you have learned in class 9. So we need two axes to reach a particular point. We need x-axis and another one is y-axis. This is horizontal line and this is vertical line. Two lines are very much essential to locate a point. One is horizontal, that is x-axis. Another one is vertical, it is called as y-axis. So these two axes are very important. Plural, axis, plural form of axis. So we need two coordinate axes, x-axis and y-axis. So it is learnt in class 7. What are the coordinate axes? First one, if a point lies on x-axis or somewhere, see x coordinate, let us take x coordinate. The distance of a point from y-axis is called as s coordinate. So now here is a point P. So I have located one point P, this red point P. And the distance from this y-axis, the perpendicular distance, this must be perpendicular. Okay, if this line segment, what is the length that it measures? That is called as x coordinate. The distance from y-axis is called as x coordinate. It is also called as abscissa. Another name for x coordinate, it is called as abscissa. So we always write that in the form of ordered pair. So inside the bracket, we will write here x coordinate and the y coordinate. Here one point, here one point. The first one always represents the x coordinate, that is abscissa. So whatever the distance I will get here from here to here, that will be mentioned in the first part. So this is called as writing the point in the form of ordered pair. Inside the small brackets, the first point is always represents the x value. Okay, so that is called as abscissa or x coordinate. Now come to this ordinate or y coordinate. Let us understand what is ordinate and y coordinate. It is the distance of a point from the x-axis. So this is x-axis. Okay, so here is a point and this distance, the perpendicular, shortest distance is perpendicular distance. The distance from this x-axis to that point is called as y coordinate. Distance from x-axis is called as y coordinate. So this distance we also write this in the form of ordered pair between the brackets. The first one we represent by the x coordinate, the second one by y coordinate. The first one always represents the x value, second one always represents the y value. What is this x means? X coordinate. Second one y means y coordinate. Now this is y coordinate, this distance, so this distance represented by y coordinate. Okay, and this distance is represented by x coordinate. So x coordinate is the distance from y axis. Y coordinate is the distance from x axis. Is it clear to all of you? We represent in the form of ordered pair. So inside the small bracket, x comma y, point P is represented in this form. This is called as representing a point in the form of ordered pair x comma y. So x represents the distance from y axis and y represents distance from x axis. So this distance is y, this distance is x. So to reach this point, see we have to move this distance from here, like this up to here. This is x. Then from here you go vertically upward, that is y. How to reach? So you can go like this in same distance. This and this both are same. Move like this. This is x value. First we will write from the y-axis how much distance you travel, that is x value. From x-axis how much distance you will travel, that is y value. From here, then here. From here to here x, from here to here it is y. So this is a way of representing the points on a plane. Now, so look at this. This is called as a Cartesian plane. Contains horizontal line and vertical line. Suppose if a point on x-axis, any point on x-axis, suppose a point is here. What is the form of this coordinates? So from here you will move up to a distance like this. This is called as x coordinate. I told you. The distance you move along are parallel to x-axis. It is called as x coordinate. So this distance is x coordinate. But you are not moving upward direction. Therefore, y coordinate is 0. See, from y axis you are moving up to that point P. But from x axis you are not moving upward. Therefore, y coordinate is 0. Any point on this will be always in this form only. You take q here. So this is q. R. I will take r. This will be x comma 0. Somewhere here you extend this one. So then again you take some point here. So yes, that also x comma 0. X value only you have to write. Y value will be 0. Keep in mind always, any point on x axis will be always in the form of x comma 0. Any point on x axis is always in the form of x comma 0. Now let us take a points on y axis. Very important thing, listen carefully. Point on y axis. See, from y axis means you are not moving along x axis or parallel to x axis. You are not moving this side or this side. So that means x value is 0. So x coordinate is 0. But here, from here to reach this point Q, you have to move a distance this much. This is called as y. So your starting point is here. You are not moving along x axis any direction, either left or right. But you are, therefore x value is 0. But you are moving upward direction. So how much distance that you are moving, that you have to mention here, y. How much distance that you move, that will be mentioned as y. So how much distance you move along x axis, that is first coordinate, x coordinate. How much distance you move along y axis, it is called as y coordinate. Any point on y axis is always in the form of 0, 1. Any point on y axis along the vertical line, the points are always 0, 1. Whether you take here or here or here, anywhere, points are always in the form of 0, 1. Along x axis always in the form of x, 0 that I have written. Coordinates of point on x axis is x, 0. The coordinates of point on y axis is called as 0, 1. I think it is clear to all of you. Since you already studied in class 9, it's only a revision now. So then, let us see now the graph of certain equations. So linear equations means equations of this kind is called as a linear equation. So any equation of this form, ax plus by plus c, it's a general form of a linear equation. Is always, if you represent that equation on a graph, you will get always a straight line. Remember that the graph of linear equation is always a straight line. Any equation of this, for example, I will take 2x plus 3y plus 6 is equal to 0. You plot this on a graph, you will get a straight line. Any equation you take of this kind, you will get a straight line only. So x degree is 1, here y exponent here, degree here 1. So the power or the exponent value is 1 here in both the cases of the variables x and y. So here, this is first one, the linear equations in two variables. The graph is always a straight line. Any linear equation you can take. Second type, you look at this, we have quadratic equation. This is a quadratic equation I have written here, that is ax square plus bx plus c. You already studied in class 10. Any equation of this kind is always a quadratic equation and its shape is always a parabola. So if you draw a graph, so you will get the shape like this. Okay, so this is the shape you will get. So this one is a straight line, this is a parabolic shape. The graph of this highest degree here 2. So such equations will always give you the graph in the form of parabola. I will give you an example. So 2x square plus 3x plus 1 is equal to 0. It's a quadratic equation. Okay, a should not be, this a should never be 0. Otherwise it will not become a quadratic equation. This graph will be always parabola. Remember, ax plus linear equations a straight line, quadratic equations a parabola. These shapes you remember. So the shapes of the equations of this kind, now you have understood. Now look at this. Let us go to this coordinate geometry now. What is this coordinate geometry? Let us understand. So it is an algebraic tool to study geometrical figures. It's a combination of both algebra and geometry. You have studied algebra, you have studied geometry. The combination of these two area, it is called as coordinate geometry. We are including algebra to learn geometrical figures. Not only the geometrical figures, we use geometrical figures or geometry to learn algebra. To understand algebra, we use geometry. To understand geometry, we use algebra. These are the things we are going to learn in this. We are going to use in this chapter coordinate geometry. Remember, it is an algebraic tool to study the geometrical figures. Okay, so that is what a coordinate geometry. Now, what is the use of this coordinate geometry? This coordinate geometry we use in different fields in our daily life. We use this in physics, we use this in engineering, we use this in navigation, we use this in seismology, and we use this in art also, to draw the diagrams, to draw the pictures. We use this in a different field. Not only this, we have many areas, but some of the examples we have mentioned here. We have got a wide applications in our daily life. Okay, now in this chapter, present class 10th chapter, we are going to learn mainly these things. Point number 1, distance between 2 points. We are going to learn the distance formula to find the distance between 2 points. We are going to learn in this chapter. The second thing, we are going to learn to find the area of a triangle. You have learned different formulas to find the formula to find the area of a triangle. For equilateral triangle you have one, for any triangle you have half into base into height. But you are going to learn a new formula in this chapter. So that is how to find the area of a triangle using this coordinate geometry. Then third point, we are going to find out the coordinates of point which divides a given line segment in a given ratio. Suppose a line segment is given, so with A and B are the 2 points. Now I am going to select one point P somewhere in between. This point P divides AB into 2 parts. One is AB, another one is PB. So in what ratio that is divided, maybe 2:1. We are going to find out the coordinates of this one using one formula. Coordinates of point P, that means x value, y value. What are the coordinates of this point P? So here this coordinates will be given, this coordinates will be given. So if these two are ratio given means we will find out the coordinates of this point P. So this thing, the third point. So we are going to learn 3 important things in this chapter. Distance between 2 points, how to find the area of triangle, and there is a formula to find the coordinates of a point P which divides the given line segment in a given ratio, 2:1 ratio or some ratio. So this is we are going to learn. So now let us start from the beginning now. The coordinate geometry. One situation. Let us take a situation now. Carefully observe here. So very interesting. Town B is located 36 km east and 15 km north. This is the condition north of town A. There are 2 towns, town B and town A. So here I have taken town A, here I have taken town B. So what is that they are telling? Town B is located 30 km towards east. I have written the north, east, south, west here. So this is east, north, west and south. Directions I mentioned. Town A is here. From town A, the town B is located 36 km east. 36 km east. So that means from town A towards east I am going 36 km. This is east direction. 36 km. After reaching 36 km, that town B lies 15 km north. 15 km north. North means upward. From again here I have to move 15 km. So from A, go towards east direction. Go to in the direction of east 36 km. From there you move towards north about 15 km. Then that is the point town B. We get the town B. This is how you are going to address, give the address of the town B or town A. So now A and B are 2 cities or towns located with this condition. From here to here 36 km, from here to here 15 km. Now I want to find out the exact distance between these 2 towns A and B. What is the distance between these two? AB. You know this distance, you know this distance. Tell me how to find, do you find any idea how to find the AB distance? It is by Pythagoras theorem because it is a right angle triangle. This angle is 90 degree. If you use Pythagoras theorem here, see in the right angle triangle, square on the hypotenuse is equal to sum of the squares on the other two sides. Use this theorem, apply and find out the AB. We can find out the exact distance between, the shortest distance between the two towns. Okay, so this is one situation. Is it clear to all of you? Okay, now I will take another situation. 2 points lie on x-axis now. 2 points lie on x-axis. How to find the distance now? Here is point A and here is point B. Both are on x-axis only. Point A is also on x-axis. Point B also on x-axis. How to find the distance between these 2 points? It's straight line. It's all in straight line on x-axis. But here it was not like that. B is somewhere and A is here. We know horizontal distance and vertical distance we found out. The case 2, second situation, both are in the same direction along x-axis only. Now how to find now? This is, yes, Manoj?
So point B minus point A.
Point B minus point A, instead of that, you call this as OB minus OA. It's a line. The distance you say, so I want the distance between 2 points AB. I want to know how to represent the distance between two. AB is the distance now. How to find AB? It is the distance difference between, so 6 means 6 units from 0. 1, say, here, sorry. 1 second. So this is 1, 2, 3, 4, 5, 6, 7. See now, this 7 distance, 7 is the distance from this origin or from y-axis. 1, 2, 3, 4, 5, 6, 7. 7 units are there. Okay. So now this town, this A, 3 units away from this axis. So I want to find out the distance AB means you call this OB minus OA. OB minus OA. OB is the total distance, OA is this distance. Subtract this OA from OB. OB is 7, OA 3. So that is 7 minus 3 is 4 units. So the distance between the two places AB is 4 units. It is very easy if both the points on the same axis, direct subtraction only. OA minus OB minus OA. If they are on the same axis, x-axis. Now, so now if a point lies on y-axis, the another situation, how to find the distance? Here I have taken this is 0, O, point O. I want to find out the distance PQ. Tell me how to find the distance PQ.
So OQ minus OP.
OQ minus OP. OQ is the distance from the origin to this point Q, 6 units, minus OP is the distance from origin to the point P, that is 2 units. So it is 4 units. So we have 4 units, PQ is equal to 4 units. That's how, see, if the points lies on x-axis, is easy. If a point lies on y-axis, is easy, direct subtraction only. Now let us go to another situation now. If one point on x-axis, another point on y-axis. This is the third situation. Point A is, see, point B on x-axis, point A on y-axis now. One point B on x-axis, one point on y-axis. Pythagoras theorem. Very good. Now, yes, how to find AB means, so now look at this. This distance you can calculate. OB distance you can identify by looking this graph, Cartesian plane. What is the distance here? OB? 4. OB is equal to 4 units. And then OA is equal to 3 units. So use the Pythagoras theorem. What is the Pythagoras theorem? AB square is equal to OB square plus OA square. If you use OB square, 4 square plus 3 square. So 16 plus 9. So it is 25. So AB square is 25 means AB is equal to 5 units. So you will find out this 5 units. Okay. So if points, one point lies on x-axis, another point lies on y-axis, then also you can use Pythagoras theorem. You can find out the distance between the 2 points AB. Easy to find out. You can find out OB, you can find out OA, then apply Pythagoras theorem. Easily you can find out. This is the third situation. Now let us take one more situation here. With the points not lying on either an x-axis or an y-axis. Here is a point P and Q. They are not on. P is a point here. Q is a point here. I want this distance PQ. How to find this distance PQ now? This is a question now. They are not on x-axis. They are not on y-axis. So for this, see now we are going to do some construction here. All of you look at this now. So now what I will do, I am going to draw a perpendicular line from this P. Okay. What is the distance from here to here? From X, 4 units. 4 units. This is 4 units. Now from here to this point I am going to draw. So now this is okay. What is the distance?
10 units.
9 units. This is 9 units. Isn't it? Not 9. This is sorry. This is 3, 4. This is 7, 7. So this is 7. X value is 7. Y value also 7 now. So now this distance, vertical distance, you can look at this. This distance is 7 units. From here you are moving up to here by 7 units. Okay. So now after this, you have to find out a line. How to find this? You join this line now. Join this line. You call this as R now. Now you have to find out this distance, PR. Here is a right angle triangle now. Right angle triangle. So you want to find out this PQ means I should know this distance and I should know this distance. I have to find out these two distances. Now using this Cartesian plane, you have to find out the distance between these 2 points. How to find this distance now? OP. So PR. PR distance is same as this distance. Is it clear? Because it is a perpendicular distance. I will call this as S, this one as T. Tell me what is the distance PR? PR is same as ST. I say this PR is same as ST. ST can be calculated as already I told the points are on x-axis only. Points are x-axis only. This distance OT minus OS. OT 7, OS is 3. OT minus, so this is OT minus OS. OT here 7, OS is 3. So 4 units. So you got this is 4 units. Similarly, you have to find out this distance QR. How to find this QR now? QR can be written as, this distance can be written as QT minus RT. I will write it as QT minus RT. Is it clear? QR, this distance, total distance minus this. So QT minus RT. QT I will write as this. RT and PS are both are same. RT and PS are both are same. So now what is this distance QT? From here to here you know already you know that. From here to here 7 units. Minus this is same as this one. This distance you know. What is this distance? What is this distance? From here to here.
4 units.
4 units. You have moved 4 units. So subtract this one. 7 minus 4, 3. So this distance you got 3. So we are calculating the distances indirectly. You got a right angle triangle here. Apply Pythagoras theorem now. Again, PQ square is equal to, you can write PR square plus QR square. PQ square is PR square plus QR square. PR square 4 square, QR square it is 3 square. So 16 plus 9 it is 25. So you want PQ means square root of 25, it is 5 units. So you got this distance also 5 units. So this is how you find out the distance between any two points on a plane. This is the basic concept. We use this concept to discover a formula to find the distance between any two points on a plane. So now we are going to derive a formula that is called as a distance formula. So let us discover it now. Distance formula. So how to find the distance formula? Let us see now. We are going to discover a formula here. For that, let us take a Cartesian plane here. I am going to take a Cartesian plane here, x-axis and y-axis. So you can take this as x-axis and this is y-axis. Okay. So this is origin. So now I am going to locate the points on this plane now. I am going to select 2 points on this plane. So point P here, point Q here. This is point P and there is point Q. So I am going to join that points by a straight line. I want this distance PQ. So for that I want to know what is the distance of this point, coordinates of point P I want. What is the distance from this y-axis to here? What is the distance from x-axis? So I will take that as x1, y1. And I will take this as x2, y2. Is it clear? Coordinates of point P, x1, y1. Coordinates of point Q, x2, y2. So that is nothing but, see these coordinates 3, 4, 7, 7 we have taken here now. So same way I am going to take in the form of variables x1, y1, x2, y2. So now same method let us follow here. So I will write the coordinates of the point P. Let the points P and Q with the coordinates x1, y1 and x2, y2 on plane line. We have taken 2 points x1, y1 and x2, y2 on the P and Q. Now let us find out the distance P and Q now. For this, so we have to draw some perpendicular. Draw PS or PR perpendicular to OX, perpendicular to x-axis. Okay, and then draw QS perpendicular to x-axis. So these are the things we are going to do now. So I am going to draw perpendicular lines to this. So now this is perpendicular. As I told, it is PR. From here it is PQS. And then join this line. So join or draw another one. I take PT perpendicular to QS. Draw PT perpendicular to QS. So let us join this one. We call this as PT because we want a right angle triangle. So now same method let us follow here. I want to find out this length PT and I want to find out the length QT. So PT, how to find PT? PT length is same as RS. PT is same as RS. Okay, the distance PT and RS are same. PT is equal to RS. RS can be calculated as the difference OS minus OR. OS from here to here distance, same distance you can see here. Along x-axis, how much distance we are having? This distance, it is given here. Horizontal distance of this point Q. OS is the horizontal distance of this point Q. From here to here, how much distance you are going? That is x2. OS is x2. You should understand this very carefully. OS is x2. Then OR from here to here. How much distance along x-axis? x1. Is it clear? OS is the distance of this point Q from this y-axis. OR is the distance of this point P from y-axis. OR is x1, OS is x2. So now x2 minus x1. So we got this point. Similarly, I want QT. QT can be written as QS minus TS. QT, this distance, QS minus TS. TS and PR are same. So QS minus instead of TS, I write PR. Instead of TS, I write PR. So therefore QT will be equal to, what is QS? Tell me, from here to here, what is the distance? What is the distance from S to Q?
Y2.
Y2. So you can write Y2 here. What is this distance? PR. This distance.
Y1.
Y1. So you can write here Y1. So you got QT. This distance. Y2 minus Y1. This distance. X2 minus X1. So remember this is, so I can write X2 minus X1. This is Y2 minus Y1. So after getting these 2 points, so you got this PT, X2 minus X1, QT, Y2 minus Y1. Apply Pythagoras Theorem here now. Pythagoras Theorem to the triangle PQT. In triangle PQT, angle T is equal to 90 degree. So therefore by Pythagoras Theorem, PQ square, hypotenuse square, PQ square is equal to PT square plus QT square. PT square plus QT square. This is by Pythagoras Theorem. What is PT? You already calculated. What is PT? PQ square is equal to, come and tell me what is PT here?
x2 minus x1 whole square.
X2 minus x1 whole square. QT, in place of QT I will write y2 minus y1.
y1 whole square.
So this is PQ square. I want one with the length PQ. So therefore PQ will be equal to root of x2 minus x1 whole square plus y2 minus y1 the whole square. This is the formula to find out the distance between any 2 points on the plane, and it is called as distance formula. So this is called as distance formula. Is it clear to all of you? So distance between points P and Q, if these coordinates are known, x2 minus x1 whole square and y2 minus y1 whole square, add them and take the square root. Very easy to remember. PQ, the distance you want means, first x coordinate you subtract, x2 minus x1 the whole square plus y2 minus y1 the whole square, and they take this